So today we're going to talk about tape measures and measuring in general. Um, I have a few tape measures here. To begin, like this Taylor's tape measure, it's a tape measure, it's accurate, but it's really flimsy, it's not for furniture making, so that's something we want to avoid. Um, Next, if we want a tape measure, we want one that has a locking device that allows this tape to stay open when in use. So something like this, while it's nice and small and handheld, I tend to stay away from it as well. Typically I use a 12-foot version of this exact tape measure, and I can't seem to find mine right now, but this is going to be great for instructional purposes because the tape is nice and wide and it's easy to read. Okay, this is just another version of an older 25-foot tape. Okay, but what these both have are important features to note. So they're both 25-foot tapes. They both have this locking device right here in the front of them. They both have this belt clip, okay, which some people like and some people don't, but they can be removed if you don't. And then you'll notice here it says plus 3 inches, and here it says plus 3 inches. And on all tape measures, this is going to tell you the length of the body of the tape, so that if you're measuring something between two things maybe, right, you can figure out what your measurement is. You can't see it from the overhead camera here, but you could add 3 inches to the measurement coming out of this. I don't think that's the most accurate way to do it. Typically, I would maybe measure from this side to the 5-inch mark, make a pencil mark, and then turn the tape around and measure from the other side to the 5-inch mark. Okay, and then add those two together and say that's 16 inches. Okay. So we're going to go ahead and keep talking about this tape just because it's nice and big and easy to read. You'll notice that the blade is concave in shape. That's to give it rigidity, right, so that it can stay straight as I extend it. There's eventually a breaking point on every tape measure, what we call the reach of the tape measure, where if I extend this far enough, it snaps, okay? And so I got almost 8 feet. That's pretty good. That's because the blade of this tape measure is 1 inch wide. You could probably get away with having a tape measure that has a locking device where the blade is 1/2 inch, like this one. But I tend to stay in the 3/4 and wider tapes because they're just easier to handle. Next, you'll note this tape has a hook, and this hook wiggles in and out, okay? And that's actually by design. That doesn't mean the tape measure is broken or malfunctioned or anything like that. Okay, and so that is because if I hook my tape to a piece of wood and I pull it, I want that tape measure to give me an accurate reading, okay, and it does. But if I have to push my tape against the wall, the hook now retracts the thickness of itself, allowing me to still get an accurate reading, whether I'm measuring the inside of something or measuring the outside of something. So that's really important. It's also important to note that that hook is nice and perpendicular, square to the blade, right? If it is bent this way or this way dramatically, it's going to give you a false reading at times, and that's going to leave us being inaccurate. The next thing we want to know is just all the information, all the notation, the tick marks, right? Everything going down the tape. There's a lot of stuff going on here. There's black numbers, red numbers, arrows, diamonds, red squared numbers, right? And so most of what that is are things that allow carpenters and craftspeople, construction workers, to easily figure out dimensions without having to do math, right? There's some standard that says every 16 inches, when we're building a wall, there needs to be a stud. And so then if you add 16 to 16, you get 32 and 48, so on, etc. So now they don't have to think about that when they're doing their work. There's also the red numbers you see above the black ones, and that's just saying, okay, after 1 foot, we have 1 foot and 1 inch, or 1 foot and 2 inches. But I would like us to get used to just using the black numbers. Even if we have 108 inches, I prefer us to call it 108 inches and not 9 feet. Okay. So the other important thing that I think we should all know, both for this class and for life in general, is just how to read these tick marks, right? There's a lot of tick marks between every inch. They're all spaced out the same amount, okay, but what does each one mean? And so to explain that a little bit, I'm going to show you kind of an enlarged version of one of these inches here. So on this piece of paper, I folded it 4 times in both directions, giving me this grid of 16 squares by 16 squares. Now, every inch on our tape measure is broken up into 16ths. So if you count every single one of these ticks, there's 15 of them between the first line that goes all the way across and the second line that goes all the way across. So the lines, like we see here, that go all the way across are our whole numbers, our inches, okay? Now the lines vary in height depending on basically the denominator of the fraction. So in fractional math, the lower number in the fraction is the denominator and the higher number is the numerator, okay? That's about as much math as we're going to do in this class. So the longest line that doesn't go all the way across is a 1/2 inch mark. The next longest line that doesn't go all the way across are 1/4 inches, right? 1/4, 2/4 is the same as 1/2, so we always call out the number that has an odd numerator, right? There's no even numbers on the top of our fractions. So 1/4, 1/2, and 3/4. Okay, and if we go down one more, we go to eighths, and so we have 1/8. 2/8 again is the same as 1/4, so we're going to call that 1/4. 3/8, 4/8 is a 1/2, 5/8, 6/8 is 3/4, and 7/8, right? And then if we go down one time more, those tiny little tick marks, well, those are 16ths. 1/16, 3/16, etc., all the way up to 15/16. So if we look at our tape measure, we can see that the lines don't go all the way across, that those are our fractions, those are our halves, and we're always just dividing those in two. So 1/2 of an inch is a 1/2 inch, right? And that's the line that doesn't go all the way across, it's the longest. Well, a 1/4 inch mark or a 3/4 inch mark would be the next longest line. An 1/8 inch mark would be the next longest, and a 16th inch mark is the next longest. So if I say I want to find 11 and 11/16, well, I could count every single one of these tick marks to get to 11/16, or I can refer to this drawing and say, okay, 11/16 is 1/16 smaller than 3/4 inches. And so I can find on my tape 11 3/4 because I know the length of the line indicates that that's a 1/4 mark, and go back down one. And so with some practice, you'll get pretty good at calling out measurements as you read them. Now I want to talk about helpful tips and tricks of using a tape measure. And this first one I'm going to show you is one that I use all the time. Okay, if I measure across the width of this board, it's supposed to be 5.5 inches, right? It's a 1x6. We talked about dimensional lumber being slightly smaller than the whole numbers that it's called out as. So this is 5.5 inches wide. But if I look at my tape, it's actually a 1/16 of an inch smaller than that. And I don't want to figure out what 5 and 7/16 is divided by 2. So in order to circumvent that, I can take my tape and skew it. And I want to skew it until the edge of my tape is at a whole number, because I can easily divide whole numbers in half. So with my hook tight to one side and my tape skewed, I can then now make a pencil mark at 3. And I know at the convergence of those two lines, that's the middle way, the halfway point of my board. And if I wanted to know what that number was, I could measure it from both sides and say, okay, yeah, that's the same measurement. So on the theme of not having to do any more math, if I want to know what half of, say, 18 is, I can bend my tape measure and bring the hook out to 18, and then if I look in the gap, granted the number is upside down, that's supposed to be a 9, it tells me what the center mark is. And so as I move the tape to the number I want to divide in half, it tells me what the number is. You can also do subtraction this way. So if I want to know what 2.5 is less than 18, well, if I line the hook up at 18 and I count back 2.5, I can see right where my thumbnail is there, 15.5 is 2.5 less than 18. The last thing I want to talk about is just making marks off of the tape measure onto our pieces, okay? And I talk about this a little bit in the sawing and layout video, but I'm just going to reiterate here. You'll notice that when I made this mark earlier, I made a little triangle. And so, say I want to make a mark at 18 inches, if I take and hold my pencil right on that line and then pull away at an angle and pull away at another angle, I know that at the convergence of that arrow is the measurement I want. So if I walk away from this board and I come back, I'll always know what my measurement is where these two lines intersect. If I went and I was kind of sloppy and say I wanted to make 19-inch measurement and I did that, well, because that line that I made is at an angle, I don't know if that's my measurement or that's my measurement, okay? And so it's really helpful to be as accurate as you can, and this is a really good way to. If we do decide to make a line off of our tape, right, notice how I hold the tape down on the side that I want to make the line. Because it's concave, if I'm not touching the tape and I try to make a mark, my pencil, you can't really see it in the camera, but my pencil is not accurately near enough to the tape to where if I'm looking down at a certain angle at it, I might make a false measurement. So I'll hold the tape down to the material like this to where I can see the line touching, and I'll start with my pencil on the tape measure, and then I'll make a line as straight as possible, okay? The thinner that line is, the more accurate it's going to be. Right? If I take and make a mark, and I do that a bunch, well, now that pencil mark is thicker than the line on the tape measure, and so all these little things lead to inaccuracy, and that inaccuracy can build up over time. Okay?